Hello, Math 8 students. This is Open Up Resources, Unit 1, Lesson 5, Coordinate Moves. To get started today, you have 4 different options down below. I need to know which of those 4 options will take triangle T to triangle U. Select all that apply, so there might be more than one correct answer. So I'm going to pause the recording as students take a second to evaluate, is translating this way going to work? Is translating this way going to work, etc. So pay attention to the words and the terminology that are used and discuss at your tables which one of these will take triangle T to triangle U. We'll pause the recording as students discuss. Ready, set, go. All right, let's discuss these. Which one of these is going to work, and make sure you explain why. Go ahead and get us started, Ryan. How do you know number 1 will work? Great. We would call those corresponding points, right? So if you're going to call this A, and A translates over here to 1, 2, it would be called A prime. And so option 1 is going to work. Bethany. Yeah, great. So if we called this one B, it would translate to 0, -1 and be called B prime. Love that. Then I have a question about this one. What about 2? Because I have 2, 1 and -2, 1, and those are corresponding points as well. So how come no one's selecting that one? Jason? Great. Yeah, this one's going to go backwards. This one goes triangle U to triangle T, which is not what we are trying to do. What about number 4? 1, 2 to 2, 1. Bethany, do you want to talk about that one? Mm-hmm. Yeah. This one is just going from this point to this point. It's not moving from triangle T to triangle U. So today's lesson is all about the moves that we make on a coordinate grid and how it affects the actual coordinates. That's why it's called coordinate moves. So throughout this lesson, I want us to really figure out what's happening with the coordinates as we're making these various moves. So to get started, we're going to plot some points. This is just a quick reminder. The first coordinate is our x value, and the second coordinate is our y value. You'll also see our axes are labeled. This is our x-axis, and this is our y-axis. So the first coordinate, the x-coordinate, tells us how far over I need to go. The second coordinate, the y-coordinate, tells us how far up and down I might need to go. So for this first one, I'll graph it in red. A is 0.5, 4, so that's over 0.5 and up 4. So I'm not even going over a full grid line. I'm going over to the right, half a grid line, and then up 4. I'm going to the right and I'm going up because they're both positive. B, -4, 5. So since this is a -4, I'm going to be going over to the left into the negatives. And then I'm still going up 5 in the positive direction. That's going to be point B. I'm going to go ahead and label these as I graph them. I have A, I have B, here's C, 7, -2. So that's a positive 7, so I'm going to go right 7, and -2 means I'm going to go down 2. Going up and down in the negative direction means I'm going down, and there is C. Here is point D, 6, 0. That means I'm going to go over 6 and up 0, so I'm actually going to stay on the x-axis. And E is over 0, up -3. So again, that's over 0, so I'm going to stay on the y-axis. Up -3 means I'm actually going down -3, and that's going to be point E. Okay, Everyone should have those graphed right along with me. And now what we're going to do on the coordinate plane, we've already done part A. Part B, use the x-axis as the line of reflection and plot the image of each point. So that means I'm doing a reflection over the x-axis. This line here is my mirror line, and what's going to happen with each of those points. We're going to pause the recording as students try and figure that out. As you do that, make sure we label each one, A prime, B prime, etc. And then I also want us to focus on those coordinates. So I'm going to rewrite the coordinates after I do that reflection. We're going to pause the recording as students take a chance to do that in class. Ready, set, go. Okay, I want to share some various strategies that I saw students doing as they were doing these reflections. The first one is that they tried using their tracing paper in order to show these reflections. So to mimic that, I am going to do something like this. When I do this with my tracing paper, I first have to make sure that I trace not just the point, but I also have to trace the line. And then I would have to flip my tracing paper and then realign that line back into place. And it would look something like this, where A has now flipped over that line, and this is now going to be A prime. That is one way that you can do these reflections, especially when we use our tools from our toolboxes. However, I would like to remind us how those reflections work, and we've talked about this in our previous lessons. Each point is staring straight into the mirror. So B is staring straight into the mirror. We stare into the mirror at a right angle, and that point is going to be the same distance away from the mirror, but on the other side. So B is 1, 2, 3, 4, 5 steps away, staring straight into the mirror. So B prime is going to be on the other side, 1, 2, 3, 4, 5 steps away, staring straight back at it. So that might be a little bit easier than having to trace each of those points on your tracing paper. C started off down here on below the mirror line. So when it is reflected, it is 2 steps away on the other side. So it's now on the positive side. That's where we will find C prime. D, an interesting thing happens. If you touch the mirror, then your reflection is also still touching the mirror. So D and D prime are the same point. 0 steps away from the mirror, so 0 steps away on the other side. And E is 1, 2, 3 steps away from the mirror, so E prime is going to be 1, 2, 3 steps away on the other side. Okay, I've labeled each one. Now I'm going to label them using their coordinates. So here was A. A was 0.5, comma 4. But what are the coordinates of A prime? For anyone who has made it that far, what are the coordinates of A prime? Gunnar. Yeah, 0.5, comma negative 4. Pay attention to what happened here. Let's move on to the next one, B. B was originally negative 4, comma 5. What are the coordinates of B prime after that reflection? Daxton. Negative 4, comma negative 5. Because I am still 4 to the left, but now I'm 5 down. Let's move on to C. C was originally 7, comma negative 2. What are the coordinates of C prime? Swede? 7, comma 2. Great. D was originally 6, comma 0, and D prime is 6, comma 0. Last one, E. The original coordinates of E are 0, comma negative 3. What are the coordinates of E prime? Isaac? 0, comma 3. What did you notice? What happened with each of these coordinates? When I reflected over the x-axis, what is it that happened? Happy to see some hands. Discuss at your tables and share your thoughts first. All right, what did you notice happen with those coordinates? Let's start with Adia. Yeah, one of the numbers went to its opposite. Bethany. Yeah. One number goes to opposite, except for on D, because what's the opposite of 0? 0. Yeah, there is no opposite. It doesn't go positive or negative, it's just 0. So one number goes to the opposite. Isaac? Yeah, the x-coordinate is the only word I'm going to change there. This is the x-axis. This is the line. But when you're saying one number goes to the opposite, it's never the x-coordinate that goes to the opposite. The x-coordinate stayed the same. Bethany? Yeah, that's our next example that we're going to take a look at. So let's really be specific here. We originally said one number goes to the opposite, but now we've really fine-tuned it and we said the x-coordinate stayed the same. So what is the number that goes to the opposite? Landon. Yeah, it's the y-coordinate that goes to its opposite. Instead of just saying one number does, we're going to be really specific and say it's the y-coordinate that goes to its opposite. The x-coordinate stays the same. I want to ask you why, so I'm going to let you ponder that. We're going to do another example. Why are we seeing this behavior? If I'm reflecting over the x-axis, why is it that the y-coordinate goes to its opposite and the x-coordinate stays the same? I'm going to leave you with that thought, explore it in your head, and now let's look at number 3. I believe that's on the next page for you guys. So we're not graphing this one this time, but based on what we saw, based on what we know now, if the point 13, 10 were reflected using the x-axis as the line of reflection, what would be the coordinates of its image? What if I reflected 13, -20 or 13, 570? What's going to happen with those? Go ahead and discuss that with your tables. I'm going to pause the recording as you do so. Ready, set, go. All right, 13, 10. If that were reflected using the x-axis, what would the coordinates be? Gunnar. 13, -10. What about 13, -20? If that's reflected over the x-axis, what would that be, Xander? 13, 20. Great. And the last one, 13, 570, what is that going to be when it is reflected over the x-axis? Landon. Great. How are you guys able to do that without graphing these points? We didn't need tracing paper. We didn't need a graph. How did we do that? Adia. Great. So if I'm reflecting over the x-axis, that means the x-coordinate is going to stay the same. So in each one of these, we can see that that x-coordinate stayed the same. Stays the same. The y value, the y-coordinate, is what goes to its opposite. And I think it's really important that we write goes to its opposite instead of goes to the negative, because if it already is negative, like -20, it goes to its opposite of +20. Okay, let's see what happens on number 4. Now I have the just a single point, just r. The coordinates of r are 3, 2. But I'm changing the mirror line now. Now the y-axis is going to be the line of reflection. So I've made it bold so it can stick out here. Our mirror line is now the y-axis. And what are the coordinates going to be when I reflect r? What are the coordinates going to be this time? So make a prediction first, and then we'll actually do that reflection. What do you think the coordinates are going to be when I reflect over the y-axis? Isaac, what do you think? -3, 2. Does anyone have any other predictions, any other guesses? Is there anybody who wants to guess 3, -2 because the x value stays the same and the y value goes to its opposite? No? How come no one wants to make that prediction? That's what we just saw on the other one, right? Austin. Yeah, we're not reflecting over the x, we're reflecting over the y, so you already suspect that something different is probably going to happen. Let's actually test that out then. Again, I could set up my tracing paper with my line of reflection, but really I know now that this point is 3 steps away staring straight into the mirror. And so its reflection is going to be 3 steps away on the other side staring straight back. There's my reflection, and what are the coordinates? They are indeed -3, 2. So what's happening here? Again, suppose you are reflecting any point using the y-axis as the line of reflection. How are you going to be able to tell what those coordinates are? You guys have made some great predictions. Now will you put it into words? I want you to discuss at your tables first, write it down, and then we'll come back together. I'm going to pause the recording as students discuss at their tables. What's happening? How are you able to make this prediction? And what's going to be happening every time? Kylia. Say that again, the right side is reflecting over the left side? Yeah, exactly. So the right side, when I'm using the y-axis as the mirror line, what's on the right-hand side, it reflects over to be on the left-hand side. So follow-up question then, what values are on the right-hand side? Xander? Yeah. Yeah, that's positive. And what are the values on the left-hand side? Those are going to be negatives, right? So if it's over here on the right-hand side and it has a value of 3, it's going to reflect over to the left-hand side where it's going to have a value of -3. Bethany, what would you add to that? Yeah, the y-coordinate stays the same this time. The x-coordinate is the one that goes to its opposite because, again, the right-hand side are the ones that have the x-coordinate that's positive. And the left-hand side is where the x-coordinate is negative. And so, to summarize, we're seeing the same type of thing, but the direct opposite of what we saw before. This time, when I reflect over the y-axis, it's the y value that stays the same. And the x value, or I should say the x-coordinate, is what goes to its opposite. These are the rules that you will learn about transformations next year. Right now, this is just kind of an idea or a concept, but you guys already have a solid understanding of these rules so far. Now we're going to increase the level of challenge here. We're now going to be changing a segment, and we're going to change it using rotations. Is everyone done writing down so I can go to the next page? Okay, to get started, I want you to make sure that you very, very carefully draw this segment on your tracing paper. And you are going to need to poke holes through A and B. That way when I move it around, I can poke through that tracing paper and draw below it onto the actual paper. So I'll give you a second to trace out A, B, drawing that line. Again, you can see that A has coordinates 0, 3, and B has coordinates 4, 2. We're going to see what happens to those coordinates as I do these different rotations. The first one is rotate segment AB 90 degrees counterclockwise around center B. So that means center B is going to be where I spin it around. So we've already poked our hole through there. Whenever we're doing those 90-degree rotations, I've encouraged you to draw that plus sign through that center point. That way you can easily track when it's gone that 90 degrees. Are you ready? Let's spin it counterclockwise 90 degrees around B. I'm actually going to pause the video. I'm going to make you guys do it on your own first to see if you can get it in the right place. And it looks like a plus sign again. How'd you guys do? Yeah? Okay. What are the coordinates now? This was 0, 3. And this, let's label it the right way. It says rotate segment AB 90 degrees counterclockwise around B. Label the image of A as C. So here's C. And what are the coordinates of C? Ryan? Yeah, 3, -2. You see any pattern in how that changed? 0, 3 became 3, -2. I don't see any rhyme or reason to it. Okay. Reset your tracing paper because you've already got AB traced. You guys have this now on your paper below. Now we're going to rotate segment AB 90 degrees counterclockwise around center A. Before you do that, imagine what's going to happen. Where is this segment going to go? It's the exact same segment. We're still rotating 90 degrees counterclockwise. The only difference is the center of rotation. Where's that going to go? Give it a try on your own first before I show on the video. All right, here's the next one. Okay, and here's our final one. We're rotating segment AB again. This time we're switching the degree of rotation. Or we're still rotating 90 degrees, but we're switching the direction. Instead of counterclockwise, as we saw in the last two, we're going to rotate clockwise. So clockwise, 90 degrees. We're also changing the center. The center is now going to be the origin. I'm going to pause as students do that one. And now let's take a look at what this should look like. Segment 90 degrees clockwise around the origin, rotating until the plus sign looks like a plus sign again. And there we have it. This time it wants us to call these points E and F. So this is going to be E and this is going to be F. What are the coordinates? Let's focus on E first. What are the coordinates of E? Bethany? Yeah, 3, 0. What are the coordinates of F? Adia? 2, -4. Do you guys notice anything here with those coordinates? I'll rewrite them. So A was originally 0, 3. It was rotated 90 degrees clockwise, and now it is 3, 0. B was originally 4, 2, and it rotated 90 degrees clockwise around the origin, and it is now 2, -4. Do you see anything interesting here? We can see it. It's sometimes hard to describe what's happening, right? What is it that you're noticing? What do you see? Caitlin? Yeah, the number switched. So what was the x coordinate is now in the y coordinate place. What was the y coordinate is now in the x coordinate place. And we're seeing something similar happening over here. X coordinate is now y coordinate. Y coordinate is now x coordinate, but we're seeing something else interesting happening. What is that? Adia? The 4 goes to its opposite. How come 0 didn't go to its opposite? Ryan? 0 doesn't have an opposite, so maybe it really does go to its opposite all the time. Yeah, that one's really interesting to see that. And a rule that, again, you will be learning more about next year. Right now, it's just the foundations that you can kind of see that there are some patterns. It's a lot more difficult to see those patterns when we don't rotate around the origin. But as soon as we rotate around the origin, then we can see those a lot easier. There's the final look of what your paper should look like, but we did all of that on our own as well. Let's go through the summary, and then we'll take a look at our cool down. We can use coordinates to describe points and find patterns in the coordinates of transformed points. We can describe a translation by expressing it as a sequence of horizontal and vertical translations. We saw that with that warm-up piece, where we can see each one of these has been translated right 3 and down 2. So right 3 and down 2. And so what I'm noticing is this point right here, 1. That is going to go to the right 3 because it is going to increase 3. 1 to the right 3 goes up 3. 1 plus 3 is 4. And as we go down 2, 2 decreases 2 as we go down, and 2 minus 2 is 0. So we can see that effect on the points using translations. The one that we made the most sense of today is reflecting a point across an axis changes the sign of one coordinate. For example, reflecting point A, whose coordinates are 2, -1, across the x-axis changes the sign of the y-coordinate. Reflecting point A across the y-axis changes the sign of the x-coordinate, making them go to their opposites. If we're trying to reflect over lines that are not the axes, it's a lot more complicated to describe. Just as rotations that are not around the origin are a lot more complicated to describe. And again, it says we don't have the tools yet to describe rotations in terms of coordinates in general. That's going to be next year that you do that. But here is an example, and you can still see some interesting patterns. So 2, 3 rotated is -3, 2. Again, we can see some interesting things like the x value is now the y value. That y value is now the x value, but we have this extra piece where we've got an opposite involved. So we have some interesting things happening here. I want you to put that to practice now. One of the triangles pictured is a rotation of triangle ABC, and one of them is a reflection. So I want you to identify the center of rotation and label the rotated image PQR. The next one, identify the line of reflection and label the reflected image XYZ. Which one is the rotation and how can you describe it? Which is the reflection and how would you describe it? We're going to pause the recording as students work on this on their own. All right, the center of rotation is going to be the origin, or point 0, 0. And I can see that ABC rotates 90 degrees counterclockwise. I can see where each of those points has gone to. So I am going to call this P, Q, and R. The line of reflection is the x-axis. A is one step away from the x-axis on the positive side, and on the one step away on the opposite side is going to be x. B is 2 steps away on the positive side, and so y is going to be 2 steps away on the negative side. So x, y, and z over the x-axis. That's it for today's lesson. Homework is the Lesson 5 practice problems. Thanks for watching. We'll see you next time.